Welcome to SAT School. I am your instructor from satschool.com. This is our second video on probability. Now let's get started. So this is where we left on last video, practice question 2. If you have not watched that video, I strongly recommend to watch that first. Click the I button above and watch that video. So here the question is from number cards, number from 5 to 20. A card is drawn at random and we have to find odd number, that is probability of getting a card having odd number. As we know, we have number which are from 5 to 20 and that gives the possible outcomes, which in this case is 16. So if you count from 5 to 20, that would be 16, and this 16 is total number of possible outcome. Now the question is to find odd numbers which are from 5 to 20. Now that becomes favorable outcomes. I mean odd numbers from 5 to 20. And those odd numbers are 5, 7, 9, 11, 13, 15, 17 and 19. So that is all together 8. We have now 8 numbers which are favorable outcomes in this case. So 8 is favorable outcome. Now we have a relation, and the relation is finding the probability. We divide number of favorable outcomes by possible outcomes. In this case we have 8 favorable outcomes and 16 possible outcomes. So if you divide, then that would be 1 by 2. So this is the probability of getting odd number. Now let's move forward. Now we have to know some terms which are used in probability. For example, an experiment. So experiment is an activity, and that activity always gives some possible outcomes. For example, when you toss a coin, that is an activity. Tossing a coin is an activity. That activity in probability is called experiment. Again, experiment is an activity. For example, tossing a coin. So tossing a coin is an experiment in probability. Now when you toss a coin, there are two possible outcomes that we know, which are head and tail. And that possible outcomes in probability is called sample space. Again, an experiment is an activity, and that activity always gives some possible outcomes. For example, tossing a coin is an experiment, and when you toss a coin, there are two possible outcomes, either head or tail, and that possible outcomes in probability is called sample space. Now when you toss a coin, the sample space would be now head or tail. So sample space is symbolically written NS. Now when a coin is tossed, NS is equal to 2. So sample space when a coin is tossed is 2, and that is written NS equals to 2. So next word or term used in probability is an event. Now what is an event? Event is simply an outcome of an experiment. As we discussed earlier, experiment is an activity. That activity always gives some possible outcomes. Let me repeat. Experiment is an activity, and that activity always gives some possible outcome. In this case, the possible outcome is either head or tail. So this getting head or getting tail, getting head or getting tail is an event. For example, getting a head while tossing a coin or getting a tail while tossing a coin is an event. So these are some terms that is used in probability. Now we have some more example. When you roll a die, rolling a Die is an activity, and that activity is called experiment in probability. So, rolling a die is an experiment. Now, when you roll a die, there are 6 possible outcomes. There may be 1, maybe 2, maybe 3, 4, 5, and 6. So, all these are possible outcomes, and these possible outcomes in probability we call sample space. As we discussed earlier, when you toss a coin, there are 2 possible outcomes, either head or tail, and that is called sample space. Now, when you roll a die, there are 6 possible outcomes. They are 1, 2, 3, 4, 5, and 6. And all these possible outcomes are called sample space, and symbolically we write sample space as ns. So here ns is equals to 6. Now here an event is getting 1 when you roll a die, or getting 2 when you roll a die, or getting 6 when you roll a die, right? All these are example of event. Now here is a practice question. This practice question is: a natural number is chosen at random from among the first 100. The question is the probability that the number so chosen is divisible by 3. Now here we have first 100 numbers. So this first 100 number is the sample space, which is ns. Now the question is to find the probability that the number so chosen is divisible by 3. So we have to know how many numbers are there amongst the first 100 which are divisible by 3. Again, the first 100 number that represents the sample space, and that is ns. So this is possible outcomes, and there are 100 possible outcomes. ns is 100. Now if let a be getting a number divisible by 3, we suppose a be getting a number divisible by 3, and we know if you divide 100 by 3, you'll get 33.33, and that gives you a clue there are 33 favorable outcomes, meaning there are 33 numbers which are divisible by 3. So NA is 33. Now finding the probability of getting a number divisible by 3, we simply write PA. So that is the probability of getting a number divisible by 3. Now we know the formula is NA divided by NS. As we discussed in previous video, NA is simply, that is, number of favorable outcome. NS is total number of possible outcome. Here we have possible outcome which is 100. Again remember, sample space represents possible outcome. Here we have ns is 100, and that 100 or ns is simply possible outcome, and this na that represents the favorable outcome, we have 33. So if you put the value, then that simply is 33 divided by 100. Again, now the question is how you know this na is 33. You can easily know this 100 is from here, because you are asked to find from amongst the first 100. So this 100 represents sample space. Now na is 33. Simply you divide 100 by 33. If you divide 100 by, if you divide 100 by 3, that results 33.33. And we ignore the number after decimal. You simply take the number which is before decimal. Again, this 100 is divided by 3. once you divide by 3, the answer will be 33.33, and you ignore the number after decimal and just you look at the number before decimal, and that is 33. And we come to know there are 33 numbers which are divisible by 3 from amongst the first 100 number, and that is how we find NA. So here is next practice question. A natural number is chosen at random from amongst the first 1000. Now this 1000 will be NS, that is a possible outcome. Here NS is 1000. Now the question is to find the probability that number so chosen is divisible by 5. Again, let A be getting number divisible by 5. Now you have to find NA. How do you find? Simply divide 1000 by 5. If you divide 1000 by 5, that would be equals to 200, and that is NA. So I want you to try this question. Complete the challenge. So this much for today. I will meet you in next video. Don't forget to subscribe and please press the bell icon so that you can get the notification. Take care.